For our next sample problems dealing with solving equations, we can see that we have now included a variable on both sides of the equation. So now what we must do is not only isolate the variable, but we have to get the two variables on the same side so that they can be simplified together. And then at that point we can isolate the variable. So now we are going to be moving stuff from each side to the opposite side, and we use the same properties to do that. So if you can see here, you can choose to do this in one step or two steps, whatever you feel most comfortable with. So we'll start here, moving, first of all, subtracting the 5n from both sides. Now this is a personal preference. I subtract 5n from both sides, and that eliminates it from the left side. Now that's going to give me a 2n on the right side. It does not matter what side the variable is on. If it's equal, it doesn't matter if it's on left or right. Some of you may have a personal preference of the variable always being on the left side, and that's perfectly acceptable. You just have to make that decision on your own. Now you can see that in the second step I need to add 9 to both sides to eliminate the 9. Now I'll also suggest to you, as you become more comfortable with this, that these two steps could be combined. You could do both of those processes at the same time if you felt comfortable with the math, and hopefully you will in a matter of weeks. So we finalize this by dividing both sides by 2, leaving us n equals to 10. And of course this is the same thing as n equals to 10. So if you got it on the left side, it's just as good. So either way is appropriate. So that's just a simple example of, instead of having one single variable always being on the left side, now we could potentially have a variable on each side of the equation, and we would have to use the same properties to eliminate or move that variable from one side to the other. But we definitely want to combine all of the variable terms together that are like terms before we start to isolate that variable. So in sample problem 2 we have two parts, a part A and a part B. So go ahead and take time now to work those two sample problems and then come back for the demonstration. Now you can see again that we have a variable on both sides of the equation. This time I'm going to actually get it over to the left side, so I'm going to add x to both sides, giving me 3x plus 6 equals 21. The reason I did that is because I wanted to try to keep it positive. I did not want a negative variable. Even though that's not a problem, we could divide out that negative. It just seems easier just to move it to the side that's going to keep it positive. So now we're going to subtract 6 from both sides. So after I subtract 6 from both sides, I'm going to be left with 3x equals to 15. Then I simply need to divide both sides by 3, and x is equal to 5. Okay, very good. So let's move over to part B. Again, I'm going to choose to add 7x to both sides. In that process, that's going to give me a positive 4x on the left side instead of having to deal with a negative. So that's a convenience to have there. And then I need to subtract 5 from both sides. I'm going to go ahead and do that in my head a little bit here without having to write it down. It'll make everything just a little bit cleaner. And then if I divide both sides by 4, you'll notice here that if I divide both sides by 4, this side doesn't divide cleanly, so I'm left with an improper fraction. Of course, anytime we get an improper fraction, we should reduce that to simplest terms, and that'll give us 13 halves. So I'll put a little box around that. Okay, and that's just another quick example of solving equations, but this time with a variable on each side of the equation.